What if the most powerful environmental cleanup tool was not a multi-billion-dollar machine, but something you could grow in your backyard for free? Welcome to the world of phytoremediation, a niche yet scientifically rigorous branch of botany that uses living plants to remove, stabilize, or destroy contaminants in soil and groundwater. This is not just gardening, it is ecological engineering. It offers a low-cost, sustainable alternative to chemical soil washing or excavation, which are expensive, energy-intensive, and disruptive to the landscape. You can learn to remediate heavy metals like lead, zinc, and cadmium, as well as organic pollutants, like petroleum hydrocarbons, using specific plant species. This skill is invaluable for urban gardeners dealing with contaminated city soil, for restoring brownfields, and for significantly reducing the carbon footprint of environmental cleanup efforts. It is a tangible way to contribute to planetary health. Let us understand how it works. Plants have evolved sophisticated mechanisms to survive in harsh environments. Some species, known as hyperaccumulators, actively pump heavy metals from the soil. First is phytoextraction, where plants absorb contaminants through their roots and store them in their biomass. You then harvest the plants and dispose of them safely, or in some cases harvest the metals for recycling, a process called phytomining. Second is phytodegradation, where plants produce enzymes in their roots, known as the rhizosphere, that break down organic pollutants like oil spills or pesticides into less toxic compounds. Third is rhizofiltration, where plant roots absorb or precipitate contaminants from water, effectively filtering it. Getting started requires precision. Step 1 is to test your soil. Before planting, you must know what you are dealing with. Use a home soil test kit or send hydrocarbons. Sunflowers are excellent for absorbing lead, arsenic, and uranium. They are fast-growing and easy to cultivate. Indian mustard is highly effective at extracting cadmium. Lead and chromium. Willow trees are great for remediating groundwater and soils with high levels of pesticides and solvents. Poplar trees are fast-growing and effective at breaking down trichloroethylene, a common industrial solvent in groundwater. Step 3 is to plant and maintain. Grow the plants in the contaminated area. Ensure they have adequate water and nutrients, but avoid adding fertilizers that might increase the solubility of the contaminants in ways that harm the plants. Step 4 is to harvest safely. This is critical. The contaminants are now in the plant tissue. Do not eat these plants. Do not compost them in a standard garden compost pile unless you are certain the compost will reach high enough temperatures to destroy pathogens and that the metals will not leach out. Bag the biomass and dispose of it as hazardous waste, or follow local guidelines for contaminated plant material. Now consider this thought-provoking science and math question. If a sunflower absorbs 0.002% of the lead in a 100 kilogram batch of soil containing 1,000 parts per million of lead, how many sunflowers, each weighing 2 kilograms and accumulating lead at a rate of 50 parts per million in its tissue, would you need to reduce the soil lead concentration by 10%? And more importantly, why does this math suggest that phytoremediation is a marathon, not a sprint, and how does that change our perspective on fast solutions to environmental crises? The answer reveals that while the process is slow, it is passive, solar-powered, and restores biodiversity simultaneously. It challenges our obsession with immediate results and highlights the value of patient, nature-based solutions. Phytoremediation turns pollution,